Okay, so good morning, students. So today's topic is the solid waste management, the first part. So we're going to talk about this. However, before we're going further to discuss about the first topic of the solid waste management, we will watch a video first.
This is the story of 3 plastic bottles, empty and discarded. Their journeys are about to diverge, with outcomes that impact nothing less than the fate of the planet. But they weren't always this way. To understand where these bottles end up, we must first explore their origins. The heroes of our story were conceived in this oil refinery. The plastic in their bodies was formed by chemically bonding oil and gas molecules together to make monomers. In turn, these monomers were bonded into long polymer chains to make plastic, in the form of millions of pellets. Those were melted at manufacturing plants and reformed in molds to create the resilient material that makes up the triplets' bodies. Machines filled the bottles with sweet, bubbly liquid, and they were then wrapped, shipped, bought, opened, consumed, and unceremoniously discarded. And now here they lie, poised at the edge of the unknown. Bottle 1, like hundreds of millions of tons of his plastic brethren, ends up in a landfill. This huge dump expands each day as more trash comes in and continues to take up space. As plastics sit there being compressed amongst layers of other junk, rainwater flows through the waste and absorbs the water-soluble compounds it contains. And some of those are highly toxic. Together, they create a harmful stew called leachate, which can move into groundwater, soil, and streams, poisoning ecosystems and harming wildlife. It can take bottle 1 an agonizing 1,000 years to decompose. Bottle 2's journey is stranger, but unfortunately no happier. He floats on a trickle that reaches a stream that flows into a river, and a river that reaches the ocean. After months lost at sea, he's slowly drawn into a massive vortex where trash accumulates, a place known as the Great Pacific Garbage Patch. Here, the ocean's currents have trapped millions of pieces of plastic debris. This is one of 5 plastic-filled gyres in the world's seas, places where the pollutants turn the water into a cloudy plastic soup. Some animals, like seabirds, get entangled in the mess. They and others mistake the brightly colored plastic bits for food. Plastic makes them feel full when they're not, so they starve to death and pass the toxins from the plastic up the food chain. For example, it's eaten by lanternfish. The lanternfish are eaten by squid. The squid are eaten by tuna. And the tuna are eaten by us. And most plastics don't biodegrade, which means they're destined to break down into smaller and smaller pieces called microplastics, which might rotate in the sea eternally. But Bottle 3 is spared the cruel purgatories of his brothers. A truck brings him to a plant where he and his companions are squeezed flat and compressed into a block. Okay, this sounds pretty bad too, but hang in there. It gets better. The blocks are shredded into tiny pieces, which are washed and melted so they become the raw materials that can be used again. As if by magic, Bottle 3 is now ready to be reborn as something completely new. For this bit of plastic with such humble origins, suddenly, the sky is the limit.
Okay, so based on the video, what we are going to discuss is currently about the solid waste and also its management. So the first question is, what is solid waste? Yeah. So solid waste is all waste resulted from the human activities that are in solid form. So it can come from the agricultural waste. It can come from the industries and also from our households. Yeah. So there are three types of solid waste. Yeah. So the first one is the municipal, and then the second one is the industrial solid waste, and then the third one is hazardous solid waste. So the top two numbers, so the municipal and industrial waste, are discussed, yeah, in this first part of solid waste management topic. Okay, so I will go to the next slide. So what will we discuss in this solid waste management? There are two topics. First is the solid waste management hierarchy, and then the second one is the properties of solid waste. Okay, so the today's topic, yeah, will include the first number only. Okay, and then next week, yeah, we will talk about the properties of the solid waste, yeah, including the physical properties, chemical properties, and biological properties. Okay, so for the solid waste management hierarchy, yeah, it will be divided, yeah, into 6 steps. So there are six steps, yeah, to manage the solid waste. Yeah, so you can see in the figure on the right here. Yeah, so the there are 4 yeah, 4 here: reduce, reuse, recycle, and recovery, with reduce as the most preferable technique. Yeah, and then followed by the reuse, and then recycle, and resource recovery. Yeah, so these 4 are known as a 4 Okay, and then it would be followed again by the incineration and landfilling. Yeah, with landfilling is the least preferable technique, yeah, to manage the solid waste. Okay, so I will directly go to the 4 strategies. Yeah, so 4, yeah, as I said previously, include a reduce, reuse, recycle, and recovery or transformation. So the first 3 is reduce. Yeah, so what can we do, yeah, to reduce the solid waste? Yeah, let me open all. Yeah. So the first technique, or the first method to reduce the solid waste is to buy the largest package. Yeah, so let's say we have 2 types of product size, yeah, 1 liter and 100 milliliter. Yeah, then in order to make up the same amount of 1 liter, then we need 1 package of 1 liter products and 10 packages of 100 milliliter products. Yeah, so the amount of packaging resulted by using 10 packages, of course, will be larger than 1 liter. Yeah, and then we can also buy the concentrated product. Yeah, some retailers have sold many concentrated detergents, and then softeners, cleaners, and some other household products. Yeah, to reduce the amount of the packaging waste. Yeah, the third and fourth are pretty much straightforward. Yeah, so we can look for a product with minimal packaging, and then we can also increase. Yeah, we will choose the product with a higher lifetime. Yeah, now reducing, yeah, is very beneficial as we can save natural resources, and then reduces toxicity of the waste and also reduces costs. Yeah, so this is the first, the most preferable technique in the solid waste management hierarchy. Okay, and then the second, yeah, is reuse. Yeah, which means we can use the product more than once for the same purpose, such as like this here, soap bottle. Yeah, so after the soap is after we use all of the soap inside the soap bottle, then we can refill the bottle with another package of soap. Yeah, so this is reusing for the same purpose. Yeah, however, we can also use the product more than once for alternate purposes. Yeah, so as you can see, yeah, you can create a vegetable pot, yeah, from the water bottle, and then you can also create a garbage can, yeah, from a water bottle, or you can also use the paper, yeah, as a stationary or a pen stand, yeah. So yeah, that's two types of reuse, yeah. So you can use the product more than once for the same purposes or for some alternate purposes. Okay, now the advantage of reuse is that does not require reprocessing, yeah. Therefore, it requires lower energy. Okay, then the next re, yeah, the third re stands for recycle. So, which is a process where waste material is reformed to a new or similar product. Yeah. Several materials that can be recycled, yeah, can be seen in this figure. There are paper, and then glass, plastic, and metal. Okay. So the question is how to recycle the paper. Yeah. So first, yeah, the paper is usually the ink. Yeah, the ink is the process to remove all the tint, yeah, all the ink from the surface of the paper, and then after that it will be crushed, and then it will be aided by some water to become a pulp, and then it will be blended with the new fiber pulp, yeah, to create another paper. Yeah, and then for glass and metals, yeah, you can just directly melt it and then blend it with the new raw material. Yeah, so as you can see on the top of the slide, yeah, that making a new glass, yeah, from recycled waste, yeah, this is from a report, yeah, that making a new glass from the recycled waste requires only 60% of energy from that using the new materials, yeah, because the recycled glass melts in a lower temperature. Yeah, so this is one of the advantage of using a recycle technique. Yeah, and then the next is plastic. Yeah, so for plastic, yeah, after it become a waste, it will be collected, and then when it comes into the material recycling facility, it will be separated. Yeah, it will be sorted, and then after that, it will be washed, yeah, to remove all of the impurities, and then melt. And then after that, it will be blended with the new raw materials to be processed into a new product. Yeah. Now, the question is why we have to separate. Yeah, because as you can see here, there is one separation step here, which is based on the type of the plastic. Yeah, as you can see here, PET has a number of 1, HDPE 2, PVC 3, and so on. Yeah, so every plastic product have their own recycling number. Now the question, why do they have to be separated? According to the type of the plastic, according to the number. Yeah. Okay, so actually, yeah, every type of plastic have their own characteristic and also behavior, either in the liquid state or in the solid phase. Yeah, so therefore, because they have their own characteristic and behavior, the recycle processing steps will be different for each plastic. Yeah, so that's why it has to be separated before it goes into the process, yeah, and the blending process with the new raw material. Yeah. Okay. Then the last three, yeah, in the 4 read strategies, the last one is the recovery. Yeah. So it is a process to recover the waste into energy. Yeah, there are 3 types of recovery or transformation. First is physical transformation, second is chemical transformation, and the last would be the biological one. So for the physical transformation, we can reduce the volume, by pressure applied compaction, or we can also reduce the size, by grind it, shred it, or mill it. However, the two transformations that we will talk about today is the chemical transformation and biological transformation. The chemical transformation include the combustion or incineration, pyrolysis, and gasification, while it would be composting and landfills for the biological transformation. So we go to the first step, which is the combustion. Or sometimes we can call it incineration or thermal oxidation. So in this technique, we convert the organic compound in waste to heat. Nah, in order to obtain the high efficiency of the conversion, we have to consider several factors, including the temperature, and then the air turbulence, and also the oxygen availability. The temperature for hydrocarbon destruction is from 900 to 1100 degrees Celsius, while for chlorinated solvent or other waste, which is difficult to incinerate, it requires a higher temperature, ranges from 1100 to 1200 degrees Celsius. And then the typical heat value, as you can see from the table 7.3 on the right hand side, the typical heat value of municipal solid waste, can be seen here. So for food waste, per pound of food waste, dried food waste, the heat value will be 2000 BTU. While for paper, per pound of dried pepper, we'll have a heat value of 7,200, and so on. Okay. So let me go to the next slide. Wait a minute. Okay. So actually, the processing steps is similar to what I have delivered last week, about the incineration. So the example of the process can be seen in this slide. So as you can see, the combustion of the solid waste, will generate, so after a combustion here, there will be another solid waste, we call it fly ash and bottom ash. The question is where to dispose these two ashes, the fly ash and bottom ash. So the first step in mind should be landfills. Yes, we can go for landfill. However, both fly ash and bottom ash, before we put it in a landfill, they have to pass through the metal leaching process and neutralization. Before it is safe to dispose into the landfills. And another alternative methods, is to valorize the ash, both fly ash and bottom ash, as a construction materials. So either landfills or you can use it as a construction materials. Okay. And then after the incineration or a combustion or thermal oxidation, we have another chemical transformation called pyrolysis, or sometimes we refer it as a destructive distillation. So in pyrolysis, the combustion happens under the oxygen-free environment. To convert the unstable organic compounds to gas, liquid, and solid fraction. The important variables in this pyrolysis technique is the heating rate and also the temperature. And as it is stated before, that it will produce gas product, liquid product, and solid product. Yeah, so the gas product includes this methane, ethane, yeah, and then hydrogen, carbon dioxide, and others. Well, for the liquid product, it would be in the form of bio oil, along with some acetic acid, acetone, and also methanol. And for the solid fraction, yeah, it would be in the form of charcoal. Yeah. Okay. So this is for pyrolysis. Yeah. So the next one is the gasification. Yeah. So this method is in between of combustion and pyrolysis technique. Yeah, we call it as a modified pyrolysis. Yeah, so it's not oxygen free, but it's also not. We do not introduce enough oxygen to convert. Yeah, to combust all of the organic compound. Yeah, so it's only limited quantity of oxygen which is introduced in the system. Yeah, where the resulting heat, yeah, is enough to make the system self-sustaining. Yeah. And then the product, yeah, there's only one product here, which is the low energy gas that can be used as a energy for chemical industries. So those three, yeah, combustion, pyrolysis, and gasifications are the three techniques in the chemical transformation. Yeah. So if we can recap it into one slide, yeah, you can see in this slide, yeah. So for combustion, yeah, the heat product, yeah, the heat product can be delivered into a boiler, yeah, for steam production or electricity generation, yeah. And we can also use, yeah, the heat directly as a heating medium as well, yeah. And then the gasification produces the fuel gas, as I said previously in the previous slide. Yeah, it can be delivered into turbine and then engine to produce the electricity, yeah, and also can be used for transportation, yeah. And then the product from pyrolysis, yeah, it has three types of products, yeah. The charcoal, yeah, yeah, it can be directly sold, yeah, to many industries, yeah, because many industries still uses charcoal as a energy to produce steam. And then another product of pyrolysis technique is bio oil, yeah, which also can be delivered into turbine and also engine, the same as fuel gas for electricity generation and also for transportation. Yeah. Okay, so up until this part, any question? Okay, if not, then we can go to the next biological transformation. Yeah. So there are two types of biological transformation here. First is composting and the second one is landfill. So composting is a biological decomposition of organic material to a humus-like stable end product. Yeah. So there are two types of composting technique. Yeah. First is aerobic. Second one is anaerobic. Yeah. So for aerobic composting, it will be conducted in the open air, and then it should have an odor-free process. Yeah. And then it requires a shorter time. And however, yeah, it will occur efficiently at right condition. Yeah. While for anaerobic digestion, yeah, it is conducted in a closed system. It, of course, yeah, create others, and it requires longer time. However, we can expect a uniform result throughout the uh, part, yeah, of the compost. Yeah. So yeah, again, yeah, a question is which one is better? Yeah, so it actually depends on the condition, yeah, on the time requirement, investment, and also the results you desire. If we require a shorter time, so of course the aerobic composting is better. While if we want a uniform results throughout all part of the compose, then anaerobic is much better since we can control every parameters. Okay. So we first go to the aerobic composting. So you can see the figure on the bottom here. So we have an organic matter, minerals, water, and microorganism as the raw materials. Then the oxygen, is required, for the aerobic condition. Now, during the process, there are three steps. There are three phases here: the mesophilic phase, thermophilic phase, and maturation phase. Where during these three phases, there are several gases released, such as water vapor, carbon dioxide, and also heat. Then, and then after maturation step, after the third step, the final compost will be formed. So this is the basic steps in the aerobic composting. Okay, so as I said previously, there are three phases of aerobic composting. So the first step is mesophilic, second is thermophilic, the third is maturation phase. So for the mesophilic phase, there is an explosive growth of mesophilic bacteria and fungi. Therefore, there will be a rapid uptake, of soluble sugar and starches in the municipal solid waste, MSW. Okay, and then after it passes the mesophilic phase, it will go into the thermophilic phase, where the growth of thermophilic bacteria and actinomycetes, which is the most heat intolerant fungi, happens. And in this phase, there is also a destruction of pathogenic microorganism, and there is also a breakdown of protein, fats, hemicellulose and cellulose in the solid waste. So after it passes the thermophilic phase, we'll go to the last maturation phase, where, I have to erase the ink. In the maturation phase, when it's still above 35, when the temperature in the maturation phase is still above 35 degrees Celsius, then the mesophilic actinomycetes, fungi, and other bacteria predominates. And in this condition, the invertebrates colonize outdoor, in the outside of the piles. So there will be like a lot of worms, usually in the outside part of the piles, the compost piles, While when the temperature reaches below 35 degrees Celsius, there is a microbial degradation. In this phase, the compounds which are difficult to degrade, in the solid waste will be decomposed, and then it will be it will form a very complex compounds, which like a humus, that is formed and stabilized. Okay, so these are the three phases, in the aerobic composting. Okay, so there are several factors, affecting the process of composting. So first is the nutrient or carbon to nitrogen ratio. So this factor is an important factor, to the nutritional needs of microbial masses. So if we have a carbon to nitrogen ratio that is too high, so that means there is a lack of nitrogen, which causes the limitation of microbial activity. However, if we have a too low carbon to nitrogen ratio, then there is a lot of nitrogen that will be lost as an ammonia ions, which increases the pH. Yeah, that is undesirable for microbial activity. So that's for the nutrient part. Yeah. Then the second one is the, oh sorry, nah, the optimum value of carbon to nitrogen ratio is 20 to 30. Yeah. So if it's too high, then it will a lack of nitrogen. If it's too low, then a lot of nitrogen will be lost as a ammonia ion. Yeah. Nah, then how to control the carbon to nitrogen ratio? Yeah. So we can try to mix the brown and green waste. So brown waste, yeah, is refers to carbon-rich organic waste, yeah, such as leaves, straw, paper, and then sawdust and animal bedding, yeah. While for green waste, yeah, it consists of vegetable scraps, coffee ground, yeah, manure, grass clippings, yeah, and others. Yeah, so we can mix it, yeah. So brown contains of a lot of carbon, while green waste consists a lot of nitrogen. Yeah, so to get an optimal value of C to N ratio, then we can try to mix it. Yeah, to mix both green and brown waste. Okay. The air requirement and also the moisture content, yeah, affect each other. So these two factors affect each other. Yeah, as moisture, yeah, usually transport oxygen in the composed material. Yeah. Now, when it is too dry, yeah, of course, the bacterial activity will be going slower. But if it's too wet, there will be a loss of air in the pile. Yeah, because the water starts to fill in the pores. Yeah, and it will lead to an anaerobic condition. Yeah, so you can imagine if it's too wet, then the water will start to fill in the pore and it will push out the air from the pores. Yeah, so finally it will lead to a anaerobic condition. Yeah. And then next factor is the particle size. Yeah. So particle size will affect the porosity, airflow, and amount of microbial activity. Yeah. So as you can see in this figure, yeah, so the porosity actually creates airflow. Yeah. So when it is very porous, yeah, it creates channel for air to flow inside, right? And subsequently increase the microbial activity. Yeah. So usually a small particles is preferable because it will create a higher porosity. Yeah, however, even though small particles is preferable, but the particle that is too small, yeah, it will decrease the porosity and airflow. Yeah. Why? Yeah. The question is why the particles that is too small decrease the porosity and airflow. Yeah. Because tiny particles, yeah, tend to form a very compact solid. Yeah. Therefore, it will reduce the airflow. Yeah, so there is a range usually for the particle size, yeah, in the composting process. Okay, and then the next two parameters, the next two factors are the temperature and pH. Yeah, so the temperature and pH, yeah, again affect the microbial activity and growth. So the optimum temperature is in this range, yeah, and then the optimum pH for bacteria is 6 to 7.5, while for fungi is like around 5.5. Yeah. Okay, so we have to make sure that all of the factors, yeah, are in the range, are within the range that is required. Yeah. Now, so this is the aerobic composting cycle. Yeah. So the first step is we receive the local greens, yeah, from the agriculture sites or from the households, yeah, or from the other industrial maybe. Yeah, and then after that the waste will be shredded, yeah, into smaller particles, yeah, before being watered and turning, yeah. And then after that, during the composting, yeah, the temperature will be regularly checked, yeah, and after the compost form, it will be screened, yeah, before it's packed into a sack, yeah. Okay, so this is the cycle of the aerobic composting. Okay, any question for this? Yeah. Okay, so if not, we will move to the anaerobic digestion, yeah, or anaerobic composting. So it has the same method as what I have explained previously in biological wastewater treatment. So where the complex organic material, such as carbohydrate, protein, and fats are hydrolyzed, as the first step into a short chain of sugars, and then amino acids and fatty acids. Yeah, and then the process continues via the acidogenesis steps where the volatile fatty acids are produced. Yeah, and then the acetogenesis, yeah, as the third step, convert these volatile fatty acids into acetic acids, hydrogen, and carbon dioxide. Yeah, and the last steps, which converts those components to methane, yeah, is called methanogenesis. So it's similar to what I have explained previously. Yeah? Now, based on the, yeah, okay, so it's the same, yeah, as in the wastewater treatment. Yeah. Now, based on the temperature used during the process, there are two phases here, thermophilic and mesophilic phase. Yeah, so for thermophilic phase, it is faster in degradation. However, it requires more energy and less stable. Yeah, while for mesophilic, it is slower, yeah, in degradation. However, since it has a greater stability and lower in cost, then usually this mesophilic phase is generally preferred. Yeah. Okay. Now, again, yeah, if previously we talked about aerobic, the factors affecting the aerobic composting, now we are talking about the 7 factors affecting the anaerobic digestion. Yeah. So the first factor is temperature. So again, there is a range here. So 20 to 40 degrees Celsius for mesophilic, 50 to 70 for thermophilic. Yeah, and the temperature must be kept, yeah, within the fluctuation of 2.8 degrees Celsius. Yeah, and then the pH is 6.8 up until 8.5. The alkalinity, yeah, the minimum is 2,500 milligram per liter. And then the retention time is like approximately 10 to 30 days. Yeah, so it's between 15 to 30 days for mesophilic and around 2 weeks for thermophilic. Yeah. Okay, so this 4, and then the next 3 is the organic loading, mixing, and nutrients. Yeah. So for organic loading, yeah, when we increase the organic loading, yeah, it will result in the higher production of methane. However, as it also increases the carbon to nitrogen ratio, then it will reduce the efficiency of the process. Yeah, yeah, and then mixing. Yeah, the 6th factor is mixing. Yeah, so mixing is required. Yeah, to ensure contact between the bacteria and the waste, and it will also prevent the formation of scum and facilitate the release of biogas. Yeah, and then the last factor is the nutrients. Yeah, where the C to N ratio between 20 to 30 is preferable. Yeah, this factor is, intercorrelated with the organic loading I explained before. Yeah. Okay. Now, this is the cycle for anaerobic digestion. Yeah, so where the first step, yeah, we collect all the food waste, yeah, manure, yard waste, and also municipal solid waste. It will be collected, and then it will be sent into a grinding or mixing tank, yeah, and then it will be preheated, yeah. This preheater is used to keep the temperature inside the aerobic digester, yeah. Yeah, so because as I said previously, anaerobic digestion, yeah, requires a very strict controls, yeah, on the temperature and other parameters. So that's why after it is greened, yeah, the waste has to be preheated, yeah, so that all of the input waste to the digester, yeah, has a constant temperature. Yeah. Now, in this anaerobic digester, yeah, the biogas will be produced, yeah, and it will be transferred, yeah, into the condensing system and also storage. Yeah, while the heat that is produced, yeah, the heat that is produced will be used for electricity, yeah, and then the solid and liquid part, yeah, obtained from this digestion, yeah, will be transferred to a separation process where the liquid part, yeah, will become a liquid organic fertilizer and the solid part become the organic compost. Yeah, so that's for the anaerobic digestion cycle. Yeah. Okay, so we go to the last part, which is the landfills. Yeah, and actually landfills is also included in the ultimate disposal. Yeah, this ultimate disposal does nothing, yeah, to reduce the waste. They only collect the waste and put it in a very compact form. Yeah. Nah, so ultimate disposal includes landfills and also open dumping. Yeah. So open dumping is this. Yeah. So the first example is open dump, yeah, where we can discharge the waste as it is in an open space. Yeah. So actually, this disposal type is the type that is commonly used in Indonesia. Yeah, and the several drawbacks. Sorry. Now, several drawbacks of open dump is, there will be like rodent and insects. Yeah, and then pollution on the ground and surface water. Yeah, and then there will be a chance, yeah, to for the spontaneous combustion to occur, and then there will be also another that is produced, yeah, in this open dump. Yeah, so this is one type of ultimate disposal, and another type is landfills. Yeah, as I previously said. Okay, so uh, in the sanitary landfills, we confine waste in the smallest area in a very compact form. Yeah, so we will reduce the waste to the smallest volume, and then after that we will cover the waste with the tops, yeah, or layer of the compacted soils, yeah, tops like this. Now, the potential hazards of the sanitary landfills include two things. First is the leachate. Yeah, leachate is a highly mineralized liquid, yeah, that is produced after the decomposition of waste. Yeah, and it is also capable to transport bacterial pollutants. Yeah, and then the second is the uncontrolled escape of methane gas, yeah, which is flammable and also potential to create other. Yeah. So these two potential hazards comes from the sanitary landfills. Yeah. Okay. Okay, so this landfills, yeah, which is the least preferable method, yeah, is what we will discuss in the next slide. Okay. So while it is not preferable, yeah, while landfills is not preferable based on the hierarchy of solid waste management, yeah, but actually this method is very popular, Yeah, and it's very commonly used in the developing countries. Yeah. Now, in order to build a landfill, yeah, we have to consider several factors, yeah, including the climate, and then the surface water hydrology, and then the geology or topography of the area, and then the location of the water and disposal zone. And then the last is the amount of precipitation in that particular area. Yeah. So one assignment for you is try to find the several reasons of why these five factors are important. Yeah. To for a site selection of the landfill. Yeah. Okay. Now, to build a sanitary landfills, we can use three methods. The first is trans method. Second one is the area method, and then the third one is depression method. Yeah, so for the first method, which is the trans method, or ya Indonesianya itu parit atau selokan, gitu ya. So this trans method is used in the flat ground, yeah, when the adequate cover material is available and the water table, yeah, is below the bottom surface of the landfills. So we can choose the trans method. Wait, let me open. Okay. Nah, so the steps is first the waste is placed in the trans, ya, diletakkan di dalam parit. Then after that it will be compacted in layer, ya, until it reach the ground level. Yeah, until it reaches the ground level. So if the ground level is this high, so the compacted waste, yeah, have to reach the same level as the ground level. Yeah, so after that it will be covered by the cover material, yeah, such as the tarps, yeah, or compacted soil and else. Yeah. Now, this trans method only have one level of compacted waste. Jadi cuma satu tingkat aja. Yeah. So therefore, it is built when we have only a little of waste. Yeah. Now, the second method, yeah, is area method. Yeah. So for a higher amount of waste, yeah, usually we use this method. Yeah. It again is used on the flat ground. Yeah. That has a specification that is unsuitable for trends. Yeah, for example, not enough cover materials to cover all of the waste. Yeah, now as you can see here, yeah, there are more than one level of compacted waste. Yeah, yeah, it is different with the trans method. Yeah, trans method has only one level of compacted waste, while area method has more than one level of compacted waste. Yeah, so since it has more than one level, yeah, of waste, so we have to have a well construction earthen, yeah, that is required before the landfilling. Yeah. Sorry. The thickness for each layer, so the thickness of each layer of the compacted waste is 2 to 3 meters, while the cover materials, yeah, for each layer here and here is like ranges from 15 to 30 centimeters. Yeah, and one completed layer of a compacted soil, yeah, we call it as a cell. So we call it as a cell. Yeah. Nah, the last method, yeah, wait. Nah, the last method after trans and area method is the depression method. Yeah, which is usually used not on a flat ground but on a hilly ground, yeah, such as canyon, dry pits, and else. Yeah. Nah, one requirement, yeah, to build the landfill, yeah, using the depression method, yeah, we have it must be built in a place where the water does not accumulate behind the landfills, so that it would not generate more leakages. Yeah. Okay, so those are the three methods, yeah, to build the sanitary landfills. So it depends on the topography, yeah, of the area, and also it depends on the availability of the cover materials, and it also depends on the amount of the solid waste that one that must be landfill. Yeah. Okay. Now, in designing a landfill, yeah, we have to build these five systems along with it. Yeah. So first is the gas monitoring system. Yeah, to monitor whether there is a gas leak from the final cap of the landfill. Yeah. And then the second system is the water monitoring system. Yeah, to again monitor whether there is leakage comes into the groundwater. The third system is the leakage management system. Yeah, to transfer the leakage produced from the landfill to a treatment. Yeah, so that it can be safely discharged thereafter. Okay. And then the liner system, which is to cover the bottom part of the landfills, and the final cover or the final cap to cover the upper part of the landfill. So it has to have these five systems, yeah, along when we want to build a landfill. Nah, okay, so for liners, yeah, it is specifically built, yeah, to prevent the leachate, yeah, from seeping to the groundwater. So the liner system, yeah, is used to prevent the leachate from seeping into the groundwater, as well as to prevent the landfill gas from migrating out, yeah, from the bottom of the landfill. Nah, okay, as previously mentioned, yeah, leachate is the mineralized liquid, yeah, that is in contact with the solid waste. Yeah, so this liquid is usually toxic and also harmful. So it has to be collected in this perforated pipe, yeah, which is included in the layer of the liner system. Yeah. And then after it is collected by the perforated pipe, it will be delivered into a holding tank, yeah, before it is sent to the leachate treatment system. Yeah. Nah, meanwhile, for the final cap, yeah, it is used to prevent the gaseous emission, yeah, and leachate escapes upward, yeah, from the top of the landfill. Yeah, it consists of two types of cover. Yeah, so the first is the low permeability layer to make sure no emission escaping, and the second one is the protective layer such as soil and vegetation. Yeah. Now, in the typical modern landfill, yeah, we usually have the gas monitoring system as well as the groundwater monitoring system. Yeah, so for the gas monitoring system, yeah, it is usually installed to check the specification of the gas, the resulting gas. Yeah, and it is also usually used to detect whether there is a methane, yeah, that is leaked, yeah, or escaped from the final covers of the landfills. Yeah. Meanwhile, the gas collection system, yeah, it is used to collect the methane gas, yeah, that is produced from the landfilling process. Yeah. Nah, let me erase all the ink first. Nah. And then the last one is the groundwater monitoring system. So it is to detect any contamination in the groundwater layer that is caused by the landfill. Yeah. So I think that's all for the first part of the solid waste management. So any questions until this part? If not, if you don't have any questions, then please work on this assignment. Answer it directly in this Google form. Yeah. So do not submit any answer to Bella. Yeah. So answer it directly in the Google form before tomorrow at the 13th of April. Yeah, before 5 p.m. So that's all from me and see you next week.